All right, here we go with 2019 FRQ number 6. Functions f, g, and h are twice differentiable. Very important that they state that right there. Okay. With g of 2 equaling h of 2 equaling 4. The line y equals 4 plus 2/3 times x minus 2 is tangent, obviously important, to both the graph of g at x equals 2 and the graph of h at x equals 2. Question A says, find h prime of 2. Okay, well, if this is a tangent line, okay, the slope at 2 is going to be the slope of this line. Okay, so the answer is 2/3. Slope here is 2/3. That was pretty easy. Probably only worth 1 point, unfortunately. All right, question B. Let a be the function given by a of x equals 3x cubed times h of x. Write an expression for a prime of x, and then find a prime of 2. All right, so a prime of x is going to be the derivative, okay, of this. And we have a product rule here. We have 3x cubed times h of x. Okay, just simple product rule. So a prime of x is going to be, first thing, 3x cubed times the derivative of the second thing. So times h prime of x plus the second thing, which is h of x, times the derivative of 3x cubed. The derivative of 3x cubed is 9x squared. And then times h of x. We're asked to find a prime of 2. So plug a 2 into all your x's. So it's 3 times 2 cubed times h prime of 2, which we found right here, plus 9 times 2 squared times h of 2, which was given to us up here. All right, so we're just going to plug in and figure this all out. 2 cubed is 8, times 3 is 24, times h prime of 2, which is 2/3, plus 2 squared is 4, times 9 is 36, and h of 2 is 4. That's given right here. All right, so work this out. We could get a calculator and do it. I'm just going to go ahead and do it in my head. 24 divided by 3 is 8, times 2 is 16, and 36 times 4 is 120, plus 24, 144. So 16 plus 144 is 160. So a prime of 2 is 160. So we have our expression for a prime of x, which they asked us to find. And we have a prime of 2. All right, C. C says the function h satisfies h of x equals this function, x squared minus 4 over 1 minus f of x cubed. For x does not equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Okay, remember L'Hopital's rule is to find the limit, you take the derivative of the top, the derivative of the bottom, and then plug back in instead of having to simplify, because obviously we're not going to be able to factor and simplify anything out of this. So we're going to have to use L'Hopital's rule. Okay, use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. So here are the two things we have to find, f of 2 and f prime of 2. Show the work that leads to your computations or to your answers. All right, so first of all, that's going to go back to this whole thing right here. Because it is differentiable, it therefore is continuous. Okay, and that continuity means something. Okay, so if you go back into your foldable, and when you want to talk about a function being continuous, the limit has to exist. Okay, f is defined at that point, and the limit equals the point. Okay, so we know that that it is continuous. So that's a big thing right there for us. All right, so you need to write that down actually. So because h is differentiable, let me slide this up a little bit. H is continuous. Okay, and since the limit as x approaches 2 of h of x is equal to h of 2, okay, we know that because the limit has to equal the point, okay? That equals 4, because we know h of 2 is equal to 4. That's given back up here. Okay, so since it's continuous, the limit as x approaches 2 of h of x equals h of 2. It just equals plugging 2 in, okay, because that's what we would do. Although we can't plug 2 into this, because if we did, we're going to get 0 on top, and we're going to get most likely 0 on bottom. Okay, that's what it would mean. All right, so here we're going to find f of 2. Okay, so that's what I'm going to do here. All right, so take a look at our numerator up here. Okay, since the limit as x approaches 2 of x squared minus 4 equals 0. How do I know that equals 0? Because plugging 2 into this, 2 squared minus 4, will give me 0. Okay, for L'Hopital's rule to work, we have to get 0 over 0, which means this. So I'm just going to write then the limit as x approaches 2 of my denominator, 1 minus f of x cubed, okay, that has to equal 0. Okay, so for L'Hopital's rule to work, and it says it can be evaluated using L'Hopital's rule. That means we have to get 0 over 0. We know the numerator is 0, and for the denominator to be 0, what has to be true is f of x cubed has to equal 1. Okay, therefore, the limit as x approaches 2 of f of x equals 1, because that has to be 1. Okay, 1 minus 1 would give me 0. Okay, because f is differentiable, I'm going to abbreviate that. F is continuous. Okay, we know f is differentiable because it told us that in the beginning. Therefore, the limit as x approaches 2 of f of x equals f of 2, and we know f of 2, or the limit as x approaches 2 is 1, so f of 2 must be 1. That's really a lot of theory and understanding about a limit and how limits work. But being differentiable implies it's continuous, and so if it's continuous, it means that the limit equals the point. All right, the next one is to find f prime of 2. Okay, since f is twice differentiable, that's given. F prime is continuous. Therefore, or so, the limit as x approaches 2 of f prime of x equals f prime of 2 exists. Okay, if it's going to be continuous, that means the limit as x approaches 2 of the f prime has to be what f prime of 2 is. All right, using L'Hopital's rule, here's what we know. The limit as x approaches 2 of x squared minus 4 over 1 minus f of x quantity cubed is equal to the limit as x approaches 2 of, now we're going to take the derivative of the numerator. The derivative of x squared is 2x. The derivative of 4 is 0. Over the derivative of 1 is 0. And now we have minus the derivative of f of x cubed is 3 f of x squared. Chain rule, the derivative of the inside is f prime of x. Okay, so now we're going to go ahead and plug in our 2. So we get in the numerator 2 times 2 is 4. And in our denominator we get negative 3. Okay, f of x, okay, f of 2 is 1. We're plugging a 2 into this. F of 2 is 1. And 1 squared is 1. Okay, so this is going to be 1 squared. And then f prime of 2 is what we have down here. We don't know what f prime of 2 equals yet. Okay, so what we do know is this limit right here, okay, this limit back all the way at the beginning here, we know it equals 4 because we have that given to us right here. Okay, so we're going to set this equal to 4, and now we have an algebraic expression where we're just trying to find this f prime of 2. So this is 4 over 1, cross multiply and get 4 is equal to, that 4 times 1 is 4, that equal to this times this. So 1 squared is 1, times negative 3 is negative 3, times that 4 is negative 12, f prime of 2. And now just divide by negative 12, and you get f prime of 2 is equal to negative 4/12, which is negative 1/3. Remember, as much as you need to, go back and just rewind these videos and listen to them so you understand those explanations, okay? This covers everything from the 2019 exam, which is the most recent, sorry, got a little dirt on there, most recent FRQ exam, AP exam that has been released, okay? Good luck with these questions, and be looking for some more next week.